Hi everyone, today we're gonna compare three different map projections: Robinson, Mercator, and North America Albers equal area Conic. We're gonna calculate the area of the state of Ohio for each map projection, and finally we will validate the results by comparison with reality. First of all, let's see how we can find boundary data. So Tiger Line is a public data source and a very important database for geographic features such as roads, rivers, political boundaries, and so forth. So let's open up your browser and Google Tiger/line. And select the first link, which is census.gov/geographies. So here is the website of Tiger Line database, which is produced by US Census Bureau. You can find the latest shapefile from 2007 to present, or ASCII format from 2006 and earlier. And if you are going to find demographic data such as age, education, income, insurance, Tiger Line doesn't include demographic data, but you can find this type of data sets from American Fact Finder, that we will talk about that in the future labs. You can find the latest shapefile or ASCII format from 2006 to present, but for 2019 I think the data is not still available. But for 2018, under 2018 Tiger Line shapefiles, you can find a shapefile for the 2018. If you select web interface, so here you can find a variety of geographic layers. For instance, if you select blocks, block group, census tract, counties, places such as cities, school district, states, zip code data, and also linear features such as coastline, roads, rails, and so forth. Okay, so it's a very comprehensive database for geographic data sets. For instance, let's see how we can download roads data. If you scroll down and select roads and then submit, here you can download national data of roads for the primary roads, or if you can download primary and secondary roads for each state separately. Okay, let's download the primary and secondary roads for Ohio. Click Ohio and then download. So again, you can see it's a zip file. If we click on show in folder, we can find the zip file. Just copy the zip file in the desktop, and let's create a folder with the name of test. Paste it. It's a zip file, you have to unzip it in the same folder, and then launch your ArcMap. So load the data. We have to connect to folder of desktop. Here is test, and here is primary and secondary roads for Ohio. Okay, so for instance, if I want to select I-71, which is from north to south interstate highway, I can use selection, select by attribute. Let me open up the attribute table first. So road type, I think full name should be I-71. So selection, select by attribute, full name equals to get unique value, and then I-71. Verify, okay, apply, okay. And you can select the primary and secondary rows for the entire Ohio. That's how you can download the geographic features and use it for your projects. You can easily data export it as a new shapefile. Okay, let's create a new map document. We don't need this shapefile for this lab. I just wanted to show you how we can download the geographic dataset from the Tiger line. So click new, create a new map document, blank map, and no. For this lab, let's download the state data. Okay, if you go to the Tiger line, go back, and here I think under state and equivalent you can click submit and then download the national file. Show folder and copy that in your lab 5 folder. Okay, GIS labs, create a new folder with the name of lab 5 and then paste it and then extract all. Go to your ArcMap and connect to folder of lab 5. So here is the state boundaries of US and is the latest version. Okay, it's for the year 2018. So that's how we can find the latest version of the geographic boundaries or other geographic features. So let's focus only on the continental US. How can I only select continental US? So from select features I can draw a box around continental US and then export it, data, export data, make sure it's only from selected features, and then save it in lab 5 folder with the name of here, with the name of continental US. US states, and then save as a type shapefile, save, and okay. Do you want to add it? Yes, and then you can remove this layer. We only want to focus on continental US. Right click and then full extent. So here is the map of US states, continental US states. Let's check the coordinate system of this layer. So how can I see the coordinate system of this layer? Right click on the data frame and then properties and then go to the coordinate system tab. So it says that the current coordinate system is geographic coordinate system North America 1983. So this is GCS, which means that the unit for measurement is based on degree, decimal degree, or degree minute second. We already know that. So here also says that angular unit is degree, and also prime meridian is Greenwich. The datum is this is NAD 83. Okay, and also we have some characteristics of the spheroid or ellipsoid. The ellipsoid for measurements of the is a mathematical smooth surface for measurements, which is GRS 80, and also some parameters of the ellipsoid such as semi-major, semi-minor, and inverse flattening. So you can find the parameters of ellipsoid, and you are familiar with these parameters. So as you know, the GCS is based on degree minute second or decimal degree, so it's not appropriate for the purpose of this lab, which is calculating area. So we should use projected coordinate system, PCS, not GCS. So we're going to calculate the area of Ohio under 3 projected coordinate system. The first one is Mercator projection, which is a conformal projection, which means that it preserves areas and is good for navigation purposes. The second one is North America Albers equal area Conic, which, as its name says, it preserves areas but sacrifices angle and distance. And the last one is Robinson, that is used to show the entire world at once and neither preserves angle nor area. So open up attribute table of a continental US shapefile and add 3 fields with double data type. Right click, open attribute table. Here we can add a shapefile, add a new field and call it area underscore A, which stands for Albers equal area Conic with the data type of float, and then click OK. Also add another field with the name of area underscore M, which stands for Mercator projection with the data type of double, and finally add a field with the name of area underscore R, which stands for Robinson, and then double data type and OK. So we're gonna populate these 3 fields with the corresponding map projection, okay, and then find the area of Ohio for each map projection. So as we are going to have 3 different map projection, and each data frame only accepts just one coordinate system. So what is the solution? The solution is to insert 2 other data frames, okay? So from insert a new data frame and also insert a new data frame. Let's rename the data frame number 1 to Mercator, data frame number 2 to Albers, and data frame number 3 to Robinson. So for the first one, we also need to change the coordinate system to Mercator. As you remember, it was GCS 83, right? So first you need to activate the first data frame and then go to the properties, and here you can search for the map projection, which is I type Mercator, click on search. So here you can find the Mercator word. Pay attention that this is projected coordinate system that allows you to calculate area, because PCS is based on length units such as meters, feet, miles. But in the GCS coordinate system, if it started with GCS, so it was only based on the degrees, decimal degree or degree minute second, and you couldn't calculate the areas, okay? So click apply, and then so this coordinate system has a geographic coordinate system that differs from one or more data sources in the map. Yeah, we already know that the data source, the coordinate system for data source was GCS 83, but this one has is Mercator, which is different, is PCS. But we know that we're gonna use it only for area calculation, so you can click on yes and then OK. So we also need to change the coordinate system for each one to the corresponding map projection. So for the Albers, we need to right click, activate, and then right click again, properties. Here you can search Albers, and again under projected coordinate system, under continental, I think North America is North America Albers equal area Conic. Okay, apply, OK. And Robinson, first you need to activate it, and then properties, type Robinson, which is a worldwide map projection. So Robinson world, okay. apply. Okay, so now you can copy the shapefile to all of the data frame. You can drag it to this one and also to this one. Okay, so you can see that the distortions of the map of US under different map projection. This one was for Robinson, this one is Albers, this one is for Mercator. So let's start to calculate area for each map projection. So let's activate Mercator. If it's not, you need to right click and then click on activate, and then open up attribute table of US, continental US, and then go to the area underscore M, which is for Mercator. Area underscore M. We should populate area for each state, or we should populate area for this field under Mercator projection. So in order to automatically calculate area or lengths or centroid, we use calculate geometry function. If you right click on the header of the area underscore M and then find calculate geometry, so you are about to do a calculate outside of an edit session, it doesn't have any influence on our analysis, so click yes. Here you can see that you can calculate area, perimeter, x coordinate of centroid or y coordinate of centroid for each polygon. Okay, so we're going to calculate area, and here it says coordinate system. Do you want to use coordinate system of the data source, which is GCS North America 83, or the coordinate system of the data frame, which is Word Mercator? Just make sure that it's PCS that allows us for calculating the area, and also it's Mercator or the corresponding map projection. And also ask me what kind of units you are going to have the area for. Each state a square meter ends up with very big values, so it's better to change this to a square miles, and then click OK. So it calculates the area for each states based on the map projection, Mercator map projection. So we need to repeat these steps for the Albers and Robinson. So first we need to activate Albers, and then open up attribute table for the under Albers, and then go to the area underscore A, right click, calculate geometry, and then properties area. We're gonna calculate geometry for North American Albers equal area, which corresponds to this one based on square miles, and then OK. So area based on Albers and square miles, so OK. So you can see that the areas for each state is different under different map projection. So let's do this for the Robinson too. So activate, and then close this one, open this one, go here, and then calculate geometry, area, projected coordinate system Robinson, square miles, and then OK and yes. So you can see that you can calculate the area for each state, such as Ohio. If I sort this and then C LMNO, Ohio, so you can have so for Ohio you can have area underscore area for under each map projection for Ohio. So now write down the area of Ohio for all of the map projection and make 3 maps in layout view. Okay, so if you close this box and then go to the layout view, you will have 3 different maps. So first one, second one, and so this one is, when I click on that, this one is activated. So this one is for Mercator. So it's better to divide this study area into 3 equal parts. Let me see if this one is equal to this one. And also, okay. So for the last one. So right click, select all of them, and then move it to the top. You can move the map, this one. And here you can clear selection for this one. So if you want to make sure, so this one is for Mercator, okay. So I can insert a title or text, okay. Insert a text, which is here. Let me move it. And then type area underscore area of Ohio Mercator. Area of Ohio, and or true or real area, true area. Change symbol to 14. Apply OK. Copy that. This one. This one is for Robinson. And this one, you can see that this one is for Albers. When I click on that, this one activates. So this one is Albers, or North America Albers equal area Conic. Equal area Conic. So now I can look at the area of Ohio for under each one. So if I open attribute table and then select find Ohio, so for the Albers is this value. I just copy this value too and then put it in front of area of Ohio. This value SQMI, square miles. Don't forget to put the units. Okay. Activate this one and then clear selection. Activate Robinson and then clear selection. So how about the reality? You can search area, US states area. Okay, Google US states area. List of US states by area. You can look at this is for validation, this is for comparison with reality, which map projection does a better job in preserving the area. Okay, so this is area of Ohio and this is the area of Ohio under square miles. So I select this value and copy that in front of the true value. This one is SQMI, square miles. You can see that Albers equal area preserved the area for Ohio, okay, but Robinson kinda shrinks the area, but here increase the area, and the Mercator map projection increase the area. So how can I remove the frames? If I select this one and then properties, and then if I go to the frame, borders to none. Okay, how about this one? Properties, borders to none. Properties, borders to none. So this is how you can compare the areas of US for under different map projection. You can see that this one, which is Albers equal area Conic, preserve the area. Here also you can type comparison of the map projections, and also put your name, or and also data source, which was tiger line, and so forth. So you can also add a label of a state's name. Okay, if you right click, for example for this one, if you right click and then go to the properties, labels, check this box, so it adds the label right for each state. But if you want to have a white background for the name, okay, this is called hollow. You can again go to the properties, label, and here go to the symbol and edit symbol, and here to the mask tab, and then select hollow. Here it adds a white background for the labels. You can increase the size of the hollow, for example to 4 or 3, and then click OK, OK, apply, OK. So here you can see that sometimes you need to add a background, kind of a white background to the names. So this is how you can label your features, and then add other necessary elements. Just remember that for the entire US you don't need the north arrow or a scale bar. And finally export your map as a JPEG file and put it into your write-up.